Okay, so this is Leetcode number 64, which is minimum path sum. So what is given in the question there? We are given a grid which is consists of numbers there, and we have to start from the top left cell, which is 0, 0, and need to reach to the bottom right cell m minus 1, m minus 1. What are the allowed moves there? We can either move in the right direction or in the down direction. So let's given in this test case there 1 3 1 1 and 1. Okay, so like what so uh, basically what we have to do, we must find the what is the total minimum total cost path. Means we have the many path there from this starting to destination, but we have to choose that path in which the total sum, or we can say the total cost, should be the minimum in the all of the path there. So that highlighted path is have minimum path sum, that is 1 plus 3 plus 1 plus 1 plus 1 means 7. If you have to try any of the other path, like if you have to go for this path or we have to choose any of the path, so it is guaranteed that its sum is either greater than or equal to some path there. So that is this highlighted part is our required answer. So what are our observation here? We have to see at any cell row comma column there. So we can come here from either from the top part or either from the left part, means row minus 1 comma column, or either row comma column minus 1 if we are to talk about the row comma column. So the cost to reach the row comma column, it depends on the minimum cost from these two positions there. So basically here we have to take choices that it comes either from there either from there. So it lets to do the recursion there, because it hints give us like if we have to multiple choices at any cell, so that means we should go for the recursion, and like after it we can say whether if we have to able to further optimize this. So see that in the coming part. So first of all, as in our typical standard recursion questions there, first of all, since this is recursion, so I have to define the my function there. So what is it? So this f of r comma column, so whenever if I've used to f of r comma column, so what it means, so it simply means we have to wait a second, row comma column there. From 0, 0. Okay, so this is the this meaning is the this gives you the minimum cost to reach the cell number row comma column from the 0, 0, that is a very starting point. So this is the basic definition of our row comma column. And like what we have to find in this question, we simply find we have to find the n minus 1 comma n minus 1. So like we can also see what is the meaning of the n or a row. I can also explain you. Okay, so like we have to find this value, and here it is as a row and it is as a column there. So to reach the row and column, what we can say, we have to reach to row comma column. So we can say one thing there, like our row comma column there. So what its value is equal to, so it means first of all what are the given value or what are the value here, since we have to reach here, so that's why we have to take its value there, and like a minimum of both of the cases there, either we have to come from the top part, so that means column there, or either we have to come from the left part, so that means the column minus 1 there. Okay, so this is the basic definition of the function of at any cell row comma column. And like one thing very well, like what is the base case to here. So here a base case, if we have to reach to 0, 0, so that is our base case. So in that condition we simply return our grid, or we can say the v 0, 0 there. Okay, so that is our value. So like I discuss one simple recursion tree for the test case, like let's zoom out this part so that it can be visible now. So here I made the one grid there, which is of 2 comma 2. I can say the 2 cross 2 grid there, and here are the values are there is a 1, there is 3, and there is 1, and there is a 5. So this is our input there, and like now we have to find what is the f of 1 comma 1, since this is the ending of the destination, like, and this is the starting. So how is this recursion tree is going on? So first of all we have to call for the f of 1 comma 1. Now it has two choice, either it come from here or either it come from here. So if we have to go to left top, so it is 0 comma 1, and if we go to left, so it is 1 comma 1. Now let's say we have to reach to here, so now it again has a two choice. F of minus 1 comma 1 means it is somewhere outside the grid, or if we have to go to left, so it is 0 comma 0. Now we don't include this part, since during our code we explicitly call our we explicitly handle all of the cases whenever we have to go exceed the boundary of our grid, so we don't have to concern about this. So similarly for f of 1 comma 0, it exceed when it comes from the left side, that is 1 comma minus 1. Okay, so like one thing here, so wait a second. Okay, so in cases of when it is going out of the bound condition, so we don't have to encapsulate those cases. But we see one thing there, like in our previous questions there, whenever we don't want that trace case, so we simply return 0, because you know those of the questions it asks me the total number of ways there. But like here we have to use either this function or either this function, and it has to take minimum. So if I take if I put the zero value stay, if I put the value 0 here, so it can be either possible like the whatever the value here it is greater than 0, so 0 might be included that disturb our answer. So since we want that our all of the cases, when we don't want the cases for out of the bound cases, we simply what we do here, so in cases if whenever it goes out of the bound, we simply put their infinity there, so that it cannot calculate it in our answer. So that means in all of the cases when it goes outside the boundary, to skip that part we simply put that value, so that by putting in this main function it doesn't matter or it doesn't affect our main answer, so that's why we put infinity. Okay, so that is like that is one good point comparing to our previous questions there. Okay, like now we see there, if we see carefully in this recursion tree, we see one thing there, this f of 0 comma 0 and this again f of 0 comma 0, this computed twice there. So basically it's showing the our overlapping subproblems, so thus our recursion become inefficient. So to optimize further it, we have to store our to avoid our recomputation, we store some values there, or like how we do storing, we simply use dp vector there. Okay, so first of all I write the brute force there, and we already know like whenever we have to write the brute force, its complexity goes in the exponential way, which gives a TLE. So to avoid it, that we have to use dp, and dp we can like use memoized version, we can further optimize it, but it for this moment we have to prepare for our interview perspective, so let's skip that tabulate part or space optimized part. Okay, so like now comes to this brute force code. Here this is simply main function given in, where I have to initialize its size and m, this is row, this is a column, and I have to pass this in our solve function. Here I pass n minus 1, here I pass m minus 1, and there's a actual input there. Okay, now is the definition of our solve function there it is a row, it is a column, it is a grid. Now first of all, this is our base case, whenever we have to reach to our starting point means 0 comma 0, we simply return that value. Okay, this is to handle all of the cases when it goes outside the boundary of the grid. So whenever if either of the cases, whether the row is less than 0 or column less than 0, it simply return the infinity value. Okay, because to skip that so that it doesn't affect our other function there, so that's why we use int max there. There's a two case from the top or from the left there, so that if we are to currently standing at the row comma column, So we have, for the top we have to call for the row minus 1 comma call. Similarly for the left, row comma column minus 1, and like return all this value. First of all, this is the value because we have to add up that value and return that value, so that's why we take the value on that current cell and now take the minimum function of the both cases, both the directions there. So this is recursion. And what is recursion? So if we have to now we talk about the what its time complexity there. So since at each of the cell here there are two options there, either you have to go up or either you have to go to left. So how many of the total of cells there's m plus n, so that's why it becomes a total 2 power n plus 1. Similarly, if you have to talk about the space complexity, so it is nothing but the O plus m, that is our recursion stack there. And like O of m plus n, or this recursion stack, like whenever we have to do recursion, so that is our extra space there. Apart from it, we don't have to use any of the extra space there. And like now we see one thing there, this is our the optimized code, which is our memoized version here. And like similarly here I use our dp vector, which is of size n comma n into m grid there, and like now pass in our main function. And this is our definition of that solve function there. This is edge cases, this is our to handle that or the exceeding cases there. This is when we reach to starting position. And here I check whether if we have to store that value already, we simply return that value. In the two cases we stored this in our that current dp cell there and simply return that value. So this is our dp solution there. And like what is its time complexity here? So its time complexity is nothing but it is O of m into n there. And what is its space complexity is nothing but of m into n and one extra space there, that is our recursion stack there. Okay, so that is of the question. And like we can further optimize this, but we don't have to go for this at this moment now. Okay, so thank you.